Good afternoon, everyone, and welcome to a webinar hosted by the Cloud Standards Customer Council, Cloud Customer Architecture for Securing Workloads on Cloud Services. My name is Tracy Berardi. I'm from CSCC, and thanks for joining us today. So this reference architecture was written by members of the Cloud Standards Customer Council. For background, the CSCC is dedicated to accelerating and drilling down into the standards, security, and interoperability issues surrounding the transition to the cloud. So we work with standards bodies, open source groups, and end-user organizations to publish vendor-neutral guides on important cloud topics, such as this paper. And our work helps to influence standards of practice by highlighting customer requirements, use cases, and best practices. So on this slide, you'll see a snapshot of some of the papers that we've published since our inception back in 2011. Brand new. We just published it this month in April, so we're glad you could join us today. We're going to walk through it. And we invite you to visit our website. It's cloud-council.org to read this material and consider joining as a member. We'll alert you as new papers are published, and you're welcome to contribute to papers that are of interest to you by joining a working group. So now I'd like to point your attention to the Attachments and Links tab in BrightTalk. We've uploaded, there's a PDF version of today's presentation that you can download. We also have a direct link on our website. I'm joined by my colleagues Chris Dotson, Alex Tumashov, Vishnu Teja Sukmana, and Bill Tworik, who will deliver the presentation. Here we go. So the Cloud Standards Customer Council has been working on this series of cloud reference or cloud solution architectures. And security, as I was saying, is the latest in this series. So on this slide, we have direct links to papers that will help you understand how to leverage the cloud for supporting e-commerce, Internet of Things, big data and analytics capabilities, mobile apps, web app hosting, social collaboration, and more. API management, hybrid integration. One second. So at a high level, these reference architectures are straightforward descriptions of elements needed to implement particular application solutions using cloud infrastructure, cloud platforms, cloud software, and cloud services. They're deployment neutral, meaning you can use public, private, or hybrid environments, and they're implementable using infrastructure, platform, or as a service. And we find that these architectures are helpful for facilitating conversation between cloud customers and vendors. So now, let's get started digging into the cloud customer architecture for securing workloads on cloud services. I'm going to turn it over now to Mr. Chris Dotson to start the presentation. Thank you, Chris.
Thanks, Tracy. So there are a lot of ways to categorize the different security controls. Four key aspects. First, we want to manage the identity and access controls so that we know who's accessing the services or applications and that they're supposed to be able to access them. Second, we need to protect our infrastructure, like the servers or the network. We need to protect our data, our applications. We have sections in the paper for each of those that we'll cover. Third, after we put the controls in place, we need to actually watch them. So security monitoring intelligence to see if any of the bad guys tripped over one of our triggers. And fourth, if we can't just put something in place and then ignore it, because security is a constantly changing landscape, we have to periodically reassess the practices, the plans, designs, tooling to keep up with the current threats in the most efficient ways we can. So many of those things are the same or mostly the same as what you do in legacy environments. What makes things a little different in cloud is that there's a split of responsibility. So in legacy, we had one monolithic provider that did everything from plug the cables in to the hardware to running the applications at the top. And with cloud, there's usually a split. One provider will handle the infrastructure, another provider everything above it, for example, or you might have 3 or 4 different groups cooperating. It's really important that everyone realizes who has responsibility for what. Otherwise, something will go wrong, and in the post-mortem, it will come out that everyone has responsibility to do something that was important. So make sure the responsibility split is written down and is understood. Now, most people are familiar with the NIST definitions of cloud, but I think it bears repeating that the deployment model you use, such as public, private, or hybrid, changes your risk posture to some degree. And the service model you use, infrastructure as a service, platform as a service, software as a service, that changes the split of that responsibility split a whole lot. For example, when I'm a customer, I'm lazy. I usually try to buy as high up on the stack as possible. So I'll use SaaS if there's an appropriate SaaS. If not, I'll create an app using a PaaS if there's a suitable PaaS, or barring that, just get some infrastructure as a service and build everything I need on top of that. So the higher up on the stack you are, the more security responsibility you've got. The less security responsibility you've got, more security responsible for your cloud provider, less for you as the customer, if you're up at the SaaS layer. Regardless, though, of which service model you use, you do always have the responsibility to verify that the service meets your security requirements before you use it, and you've got to use the service in a secure manner. So we talked about cloud security in general. Now let's look into the different items to consider when designing cloud solutions for security. So on the screen is an overview diagram showing a high-level architecture for the roles and components involved in security for cloud service solutions. The diagram is divided into three sections. There's the public network on the left. That's where users and developers and others interact with the cloud solution. There's the cloud network in the middle where the solution actually runs. And then the enterprise network on the right, which might include legacy non-cloud components. Your enterprise directory, some other data sources might be over there. Some of the items we'll talk about in the cloud provider's center section are identity and access management. So that's for your cloud admins, your application developers, your application users. You have to manage all those different roles and identities and authorize them as appropriate. Infrastructure security, network security, connectivity like VPNs, securing your compute infrastructure. We'll talk about application security to address application threats like SQL injection, security measures, vulnerabilities. Data security, finding, categorizing, and protecting your data and info assets. Secure DevOps, to develop and deploy and maintain cloud services, applications, and infrastructure. Security monitoring and intelligence, so that you know what's going on in your cloud infrastructure and applications and can manage security incidents. And then overall security governance, risk, and compliance processes, like maintaining your security policies in compliance with both industry and regulatory requirements. So at this point, Alex is going to take us through some of the details, beginning with understanding the user roles.
Thank you, Chris. So in our architecture, we define several components, or entities, if you will, that have a connection to the cloud environment. On the left side, users are the parties who interact with cloud environment for different purposes. Here they are presented at the public network layer, as this is an essential cloud capability to provide broad access. However, users can access cloud environment from an enterprise network as well. We define three groups of users. Application users, essentially people who consume services or applications. Cloud admins or privileged access users who perform administrative activities like troubleshooting, auditing, control, and configuration. Cloud developers, whose job is to improve, fix, or change services or applications as per the software development lifecycle process. All these users have different access level to different types of data and must be strongly controlled. Another essential capability of cloud environment is BYD concept, which means bring your own device. This concept splits devices used to access the cloud resources into two groups: managed devices that enterprise can control and unmanaged devices that are not under enterprise control. Depending on device type, users may have different security controls, access levels, and permissions. Again, device can be placed in both public as well as enterprise. Moreover, we may have different security controls based on the region where device is located. This may be necessary to address data residency or regulations requirements. Now let's take a look at the components located within the enterprise perimeter. The enterprise user directory is a service that maintains identities, credentials, and other information like group membership that help identify users and give them appropriate access to applications and resources. In a minute, I will explain why the directory service plays an important role within the cloud environment. Enterprise applications and data are resources that are hosted internally within the enterprise. There are several reasons to host applications and data within the enterprise network. In some cases, applications cannot be hosted on cloud because of technical challenges, for instance, legacy applications or security requirements. Also, data confidentiality, residency requirements, legal constraints, and other regulations could place restrictions on data being placed in a public cloud environment. Enterprises must ensure strong controls are in place for all connections in and out of the enterprise network. It's also worth to mention that all connections between the enterprise and cloud networks are properly secured using encryption. So we mentioned different entities that have access to the cloud environment. It is a time to define how we can control this access. Identity and access management is not a new topic. It was defined at very early stages of computer science. There are multiple components required to enforce and ensure proper identity and access management for cloud services. The first one, identity lifecycle management, allows customers to control user provisioning and deprovisioning processes, execute and monitor access requests, define password policies, and other stuff. The next one, segregation of duties, helps to eliminate conflicts of interest and helps to detect human errors. Identity as a service. With cloud environments, authentication and authorization become more flexible in terms of identity providers' range and their capabilities. And at the same time, more complex due to additional risk factors. Customers can use directory services which are cloud-based as well as on-prem versions and utilize an enterprise directory service as a single point of identities. Customers can also utilize social identity providers with OAuth or similar protocols or use an API-based authentication approach. Customers should design an appropriate cloud-based authentication and authorization approach that meets their specific security requirements. Federation services, also known as a single sign-on, provides a seamless authentication mechanism to all applications. Basically, you can manage and control only one source of identities for all your applications in and out of cloud environment. This is one of the most important tools that provides better security for both the user and enterprise perspective. Privileged access management is another big concern for cloud environment. By using PAM tools, you can centralize management of such accounts and have better monitoring and logging capabilities. Another important component is multi-factor authentication. This gives customers an additional level of security for managed and unmanaged devices. Based on device type, location, and user profile, customers can elect to enforce additional authentication factors such as certificate, token, additional passphrase, and other. As we mentioned before, BYOD is an important part of cloud computing. Mobile device management tools are designed to segregate corporate and personal data, help with the authentication and compliance requirements, as well as providing encryption capabilities. Reporting is a very important component for all systems and must be considered for cloud environments as well. customers should have a clear understanding who, when, how, and for what reason access resources. Auditing compliance. While it is a common component, it may present challenges to customers in cloud due to level of visibility and control. Some regulations require companies to perform regular audits and compliance checks on their environment. So it is necessary to make sure that internal and external requirements are met and that appropriate requirements are documented in the cloud service agreement. Cloud security services are getting very popular in cloud environments. Tools like cloud security brokers and cloud security gateways provide various security controls in cloud environments, such as integration, visibility, data loss prevention, encryption, login, malware protection, and other functionality. So that was the last component in our paper. The white paper contains details on each of them, so I encourage you to download and review the paper for more details. Now I'm going to hand off to Chris.
Great, thanks, Alex. So now that we know the identities of users and have controlled their access, let's talk about infrastructure. In the infrastructure security section of the paper, we talk about physical security, we talk about compute isolation, and network isolation. Physical security is really important, of course, because there's very few systems, aside from maybe some hardware security modules, that are hardened against attackers that have physical access. Cold boot attacks are a real thing. But fortunately, cloud infrastructure providers are generally really good about locking their doors, controlling access, anti-tailgating security cameras, things like that. So most cloud customers won't be responsible for physical security. If you are, though, there's detailed implementation guidance that are referenced, pointed to in the paper. Compute isolation is a little more nuanced than physical security. So you often have several choices for compute isolation. You can, sort of at the most secure area, you can go with bare metal or a dedicated machine where you're the only person on the physical machine. You could go with a virtual machine where you may be multi-tenant, you may be on the same physical machine as other tenants. Or you may be in a container that's running in the same operating system as other tenant containers. So depending on how stringent your security requirements are, you might want to be the only workload running on the physical machine. If you're worried about someone else on the same machine, Rowhammer to get into your virtual machine, or hypervisor vulnerabilities, or if you need to verify the integrity of the boot chain all the way from the firmware up to the operating system with things like DXT. So in cases like that, you might want bare metal or at least a dedicated hypervisor that nobody else is on the machine but you. For many customers, though, virtual machines that are on a multi-tenant host are enough isolation. The attack surface of the hypervisor that runs virtual machines is really small. It's usually a pair of virtualized drivers. And although it's possible to escape, to have a VM escape and get into the hypervisor, it's pretty rare. Historically, that's been a very rare occurrence. So, however, in addition to security concerns, you do sometimes have what I call a noisy neighbor problem with virtual machines, where one of your neighbors on the same host causes you higher latency because they're using a lot of resources. So anyway, virtual machines are enough for enough isolation for a lot of workloads. Containers are a really terrific way to package applications, but if you're in a multi-tenant environment where there's multiple containers, like from different customers on the same operating system, that's a lot lower level of isolation than the other two options. All the containers on the system do use the same operating system kernel that provides a lot of services, and so it's got a pretty large attack surface. So we recommend that if you're using containers, you're using them on your own virtual machine that you've secured. Only workloads with fairly low security concerns should probably run in containers on the same operating system alongside other tenants' containers. So that's compute isolation. When we talk about network isolation and controls, it's very important to keep your network traffic separate from other tenants in the cloud environment. One of the best ways you can do this is through network segmentation. So you put parts of your application into different virtual networks separated by controls. think of it like a building where you have different areas with guards in front of those areas to only let authorized personnel into those areas. You might have one area for your data stores where only your application servers can get to, and then only your web servers can talk to the app servers. And of course, lots of people can talk to the web servers. But it doesn't really make sense for everybody to be able to talk directly to your database, even though it should have other protections like passwords. Again, it also depends upon how sensitive you're dealing with is. So in addition to using firewalls in between your segments, you should also have one at your ingress point, which is the internet in a lot of cases. You probably, if you can, want a next generation firewall that has some sort of intrusion detection and prevention capabilities also to look for signatures of bad traffic or spot anomalies in the traffic patterns. You also may want a web application firewall that actually receives the request before the application does and checks them out. Web application firewalls are often better at things like blocking SQL injection or other, layer 7 attacks than an IPS could be. In a more complex infrastructure, you might actually also want IDS and IPS, intrusion detection, intrusion prevention, between your segments, so that if somebody gets behind there, you don't just have firewall logs, but you can also see other attacks that are inside your perimeter that shouldn't be happening. No discussion of network security would be complete without a recommendation to use TLS between each of your application components, not just on the interface to the outside, but you should do it in between your internal components as well to make it that much harder for any attacker that does manage to get a toehold in your network to do anything. TLS is cheap and it's easy. There's almost no performance penalty nowadays to using it. Don't turn off certificate checking. Yourself up to a man-in-the-middle attack. So TLS actually is typically more of an application control. It often needs to be implemented in the application. So for that, I'll turn it over to Wisnu to talk about application security.
Thank you, Chris. Thank you, everyone. So I will continue with the presentation on the topic of application security and monitoring and vulnerability. It's a big topic. For security, we have decided that these factors are important when it comes to ensuring best practices for application security. First is to implement the threat model. When discussing with your DevOps team as a security professional, it is important that we sit down with them to identify and analyze where the attack surface comes from, what are your threat boundaries, and explore potential ways that bad actors or attackers might come into your application. So this brings to the next topic of secure design. Secure by design can only come when you're aware of your threat model, essentially. This is similar exercise here to be done when it comes to analyzing the attack surface and know how to isolate your data if and when breach occurs. Next is secure coding. Now, this is covering a lot of topics, but the main points here are ensuring that input validations are done properly, ensuring that your output encoding does not reveal information that attacker might use, safeguarding your session management via various tools such as token certificates, time to live for token sessions, encrypting at rest and in transit, as mentioned earlier with the TLS, protecting your logs, etc. Next, we need to run security testing. Security testing should not just occur at the end of application development. It should start from the beginning of your application build, typically through the use of static analysis. There is a continuing challenge, obviously, considering the speed at which developments are done these days. And lastly, cloud application security controls. We need to understand what the offerings and capabilities of your cloud service providers when it comes to managing encryption, identity and access management, API security, and container security. So I will now let Bill to present his slides.
Thanks, Vishnu. So, when it comes to cloud services, especially in the case of like platform and software services where, the cloud service has access to the data itself, it really all comes down to data, the most foundational protection. Customers or data owners, they simply must trust the security that's in place to protect the data, or if they don't, there's no foundation of trust that's so essential in cloud. So The first step in data security is really truly understanding one's data and the rules and regulations that come into play for one's data. So for example, any private data, we'd be talking about future European General Data Protection Regulation, GDPR compliance, which of course has many requirements and impacts on architectures and solutions. But from there, once you understand sort of some of the rules and regulations, you have to start thinking about how do you protect the data. And protection of data doesn't have to just be encryption. You can use techniques to anonymize or de-identify the data, although they can be quite complex. But also, even when doing encryption, you have to think about, well, what's the exact right technique and scope of the encryption? Just doing storage level encryption to get a checkbox, say, hey, encryption is in place, doesn't necessarily do a whole heck of a lot, especially since that only protects from physical theft of the disk, for example. And the keys for encryption are also absolutely essential. Where the keys are, how they're managed, how you're protecting them. And encryption, when you don't protect the keys, is not a whole heck of a lot of value. So protection doesn't have to just be encryption, but when it does, there's a lot more than just flipping a bit for encryption. But beyond protecting the data, there's awareness to the actual end user and owner of data of exactly what's occurring with the data. So data activity monitoring, knowing exactly every time the data is updated, changed, removed, even when it's been added. All the activity associated with the data is essential. And having that data sort of audit trail or activity, broken down so if there are multiple tenants in a cloud service, they can see their slices of the data is an absolutely essential component. And then from there, they may know how the data is protected. They may have the trail of how it's been touched. But then they're still going to want to be and have some control of that data. So there has to be support for, the right to be forgotten that's so prevalent in European data protection laws. Secure deletion kind of options for the data to make sure that it's actually removed in a truly, destructive fashion, so that it's actually truly removed from the system. So those data access and control layers can get very granular. Also need to be per tenant, owner of the data, all those types of things. So data security is a very important element of it. So next, we would get into the category of secure DevOps. Right? So Vishnu talked through application security and all the important elements of it. But when you talk about cloud's predominantly about automation. So, the DevOps model of completely automating the entire supply chain of development through deployment and ongoing operations. Security has to be embedded in every step of that. The security testing steps that Vishnu talked through from an application level, Chris touched on from a system and infrastructure level, they have to be embedded into the automation so that you're actually performing, the code testing, the system vulnerability scans, application logic kind of scans, all that type of stuff as part of the actual deployment flows, fully operated end-to-end, fully automated end-to-end. So security DevOps is really about embedding security into the automation that's part and parcel of cloud. And then the last topic I had would get into the governance, risk, and compliance category. It's hard to talk about clouds without talking about risk and without talking about kind of compliance and industry certifications and such that are part and parcel of any cloud conversation. And when thinking about governance and risk and compliance, really the first thing that you have to understand in the cloud is where the various lines of responsibility are. In any cloud, there's a provider customer. The customer always has a level of responsibility, and the provider has a level of responsibility. And that line can vary quite widely when you're talking about an infrastructure service versus when you're talking about a SaaS service. Even in the SaaS services, there's still some security requirements, typically things like access control and such on the customer. But of course, on an infrastructure side, the service provider, the cloud provider, only takes on very lower level infrastructure and physical security responsibilities, leaving the rest to the customer. So understanding that line, really educating the business and consumers and providers on where their various responsibilities are is absolutely essential. Any governance and IT security and policies all build off that baseline. So once you know the baseline and know which side of the line you're on, then you need to understand the risk, the laws, the regulations, the organizational security policies that might come into play in that particular area. So, it's all about a risk conversation after you understand where the responsibilities lay. And policy can be a lot of it. Policies that may have existed in an organization for quite some time may need updating for cloud. They may need terminology changes to align with industry standards to help them understand what a provider or customer's responsibilities are by using terminology or other standards. And having clarity on the scope in the policy, and even things like a container. Is a container a system? Things you might need to do. Does that apply to a container? Those kinds of terminology questions in policy really need to be nailed down and thought through. And once you have that, you have the clear policy, understanding where the lines are, understanding the risks, you can start sort of mapping where organizational or customer policies might align with sort of the policies and the capabilities that are in place from a cloud. And the more you can do that on industry standards, the better. And the industry standards, again, is essential because industry compliance, industry certifications, they let someone speak a common language. So again, ISO certifications, SOC 2, Alliance, all those types of things are absolutely essential in the governance, risk, and compliance space for cloud because they're the common language that you can use to truly put all the disparate pieces of a cloud together and use common terms to talk about it. So I think I hand it back now to Vishnu for the next slide on security monitoring and vulnerability.
Yeah, thank you, Bill. So, okay, so let's move on now to security monitoring and vulnerability. This is, I suppose, a topic that is very close and dear to any ITSec operation. The goal that we want to do here is to have the ability for our IT security operations to do proactive security tracking and react accordingly to security incidents. This is especially imperative for the cloud environment, considering the fact that shadow IT is pretty much out there in any enterprise nowadays. There are a few methods to consider when performing monitoring. It's a combination of any one of these tools, implementing CASB as mentioned earlier by Alexander, or SIEM tools, security information and event management, having an MDM and MCM tool for your enterprise mobile devices, provisioning of gateways for your users. One area of interest as well is to have security analytics to detect deviation from any regular patterns, activities that exceed certain thresholds, etc. As for vulnerability management, this is also a continuing challenge that has to be managed by any enterprise who are deploying cloud solutions. However, the focus should be the same in that you must subscribe to CVE list, Common Vulnerability CVE data, to identify and prioritize the relevant vulnerabilities to be remediated, have a process to check vulnerabilities in your environment. Obviously, vulnerability management is a multi-phase process. It requires enterprises to first establish policies surrounding the vulnerability management, develop the tools and processes to scan, prioritize, and mitigate those vulnerabilities. Lastly, it is important to always maintain and monitor those vulnerabilities. So thanks for the time. I'm going to hand over now back to Chris to continue with the presentation.
Thanks, Vishnu. So to recap, first and foremost, you need to know who's accessing your cloud apps and restrict access to only those who need it and your infrastructure. We talked about a number of different ways to accomplish that, like single sign-on, identity as a service providers, multi-factor authentication, considerations such as user roles, and segregation of duties. Then we discussed protecting and securing the cloud apps, data and infrastructure, controls like firewalls, compute isolation for infrastructure, secure design and coding practices and testing for applications, data classification and encryption. We talked about monitoring and alerting, so that if someone's trying something funny, you know about it, and vulnerability management, so you can be aware of your weak spots and fix them. We talked about secure DevOps, including operational security like security scans and testing that happen throughout the software development lifecycle. We covered governance, including security policy and compliance with policies, industry regulation, government regulations and laws, privacy, lots of other items in there. And in many of those sections, we at least touched automation. None of us, I think, has an army to accomplish these things, so we do have to offload some of the work of securing the machines to the machines themselves. Automated reusable security services can help us succeed in each of the areas above. So I think that comes close to wrapping us up, so I'll turn it over to Tracy for our call to action and some additional resources.
Great. Thank you, Chris, and Bill, and Wisnu, and Alex, and everyone on the call. We have plenty of time for questions. We have some that came in. If you have any questions on your mind, feel free to enter them. We'll get to them here in just a moment. And we invite you, everyone on the call, if you're not yet a member of the Cloud Standards Customer Council, we would love to have you in our network. You can join at cloud-council.org. We have a resource hub on our website where we publish all of these papers. They're free and open access, so please visit. By becoming a member, we will alert you as new content is published, as we host webinars with the authors, and you're invited to join a working group to get involved. And here on this next slide, I jumped over it. I highlighted a couple of our security-focused papers that you might like to check out. There's Security for Cloud Computing, 10 Steps to Ensure Success, and a Cloud Security Standards Guide that goes through the various security standards that apply to cloud computing. It's a really good guide. So now on to some questions. First question is, what is the best way to manage APIs? Feel free to jump in, anybody.
Okay, yeah, Vishnu here. Thank you for the question. So API is a recent development, I think, in the cloud. And to be honest, this is still a developing field at the moment. There are some vendors out there who started to develop what's called gateways, and even the cloud service providers as well. The bottom line here is that you need to make sure that first you find ways to kind of have a common platform to develop your API within your organization. That's the first step, obviously, right? And then you develop best practices around the security of how you want to develop those APIs. And the next is to have where you pass all your APIs through this particular gateway and have it managed either through compliance or some other methods, basically, in order to be able for you to control and modify and delete the API when they're no longer needed, for instance. Otherwise, it can get really messy if everybody's developing it according to what they want to do within your developers. Thank you.
Yeah, I just second that answer. APIs, right? We're talking about security for a cloud. If you have unsecured APIs, then it's like having a nicely built strong house and just leaving the doors and windows open. So you got to have standards for APIs. So all the different development teams that might exist for a cloud service or app are all coding to the same standard and the same level of security. And as you said, there an API gateway is a good way to sort of try to have a front door for APIs to try to control some of the security in and out.
And this is Tracy here. I'll also mention that one of our other recent papers on API management, so you might want to check that out in our resource hub on our site. Next question is there a recommendation on which TLS to deploy?
Yeah, so this is Chris, I can take that one. Generally speaking, TLS 1.2 is what we recommend. 1.1 can often be acceptable too. The main thing, the biggest risk is in using SSLv3. That's pretty seriously broken. So definitely would not want to see anybody Lv3. I think it'd be a kind of an emergency situation, but preferably TLS 1.2.
And is certification enough to assure physical security on IaaS like AWS, GCP, Google Cloud, and Azure?
Yes, so I can take that. I mean, certification, an industry cert for a cloud service is an essential part of it, but it's more than just saying, does a provider have the cert? The question is, what is the industry certification? What is the strength? What are the things that are actually tested and checked by that certification? And then absolutely essential is actually getting that certification report, whatever level you can get, SOC 2, have SOC 2 audit reports, ISO 27001 certifications, give statements of applicability and other high-level reports of the audit, because you need to understand the scope that's actually included. A provider can go and get a certification from an auditor and can actually scope that certification only to cover, say, operations, but not the development side, or only development, but not the operations side. So you have to actually make sure, is the industry cert the right industry cert for trying to protect? And then, is the scope of that industry cert actually include the data center? You might have a SaaS offering that the cert was focused on all the application levels, and it didn't cover the actual data center or infrastructure elements. And then from an ongoing basis, have to continue to review that. Certs are re-upped every year, so you'd have to make sure you have a practice of renewing and revalidating and rechecking that the scope and all of that hasn't changed. So industry cert is a great tool, but you have to use it as part of an operational practice of validating cert, looking at the details, contractually requiring the provider to continue to do the cert, all of that to make this an effective control.
Yeah, and I'll add to that. I mean, we've seen certs for example, software as a service offerings, and when you actually look into what's certified, it's just the physical security controls. They're just passing that through from another infrastructure provider below them, saying, yes, we lock the doors, which is important. But as Bill says, it's necessary but not sufficient.
Yeah, it's just somebody poured a good solid foundation to put some locks on it, but then I built a house on top of it and nobody ever inspected it.
The question that just came in related says, do the certifications by the controls that can be inherited by customers?
So an industry certification typically covers the controls that the provider has in their scope. And so it will not typically then call out necessarily the controls that are on the. It focuses on validating the controls that the provider has in place. So that's another example reason of why it's important to truly understand the controls that are covered and what the cloud provider states about their controls in things like an ISO statement of applicability or the write-up in a SOC 2 audit, that type of thing. So you can understand what the cloud provider is actually doing, and then you know what has to be on your side of the controls. Still, back to that statement I made earlier of a line, looking at the cert will help you understand that line a little bit better.
Thank you. How feasible is it to monitor for vulnerabilities in a multi-tenanted environment? For example, logs may be unavailable as they may contain events from multiple cloud customers.
Yeah, I mean, I can talk to that one a little, and others can join in. I think it really depends on which level of multi-tenancy we're talking about. For example, if you're on a multi-tenant, if you're multi-tenant on an infrastructure as a service, you're building everything on top of the virtual machines, you can very easily and must monitor for vulnerabilities and things in your virtual machines. You can't necessarily see the stuff underneath there. Some of that may be hidden. Some providers do offer certain logs available that are split out by tenant, but you're entirely correct. If it's something where there's no easy way to split it out by tenant, or would maybe tell too much about how the provider's controls work, you won't be able to get that in some cases. And that's where, joining back to the previous question, that's where you tended to, instead of looking at the log specifically, you rely on a certification or attestation where tested their controls for them and looked at logs and things like that.
Great, thanks. This is the last question, unless something else pops in here. We do have some time, but if not, we can always end early. But the last question here is, what are the best ways to encourage business to invest in cloud security? Do you have any advice in this arena?
Get hacked once.
Yeah.
I can take it, Alex. I think that the best, because of business speaks numbers, right? So you need to convert all your fears or all your risks into the numbers. And the main assets we have on the clouds is our data, right? So you need to understand for yourself first what is most critical and what is risk associated with the data availability, integrity, and confidentiality, right? And then if you convert these into the numbers for the business and show them examples, there are lots of examples out in the industry, right? For the availability, we had the recent issue related to the AWS, right? Integrity as well, and confidentiality when people steal the data out of the cloud. And when you analyze your threat vectors or surface, right, and convert it to the numbers, then this message will be better accepted by the business and understood by the business than when you talk with the specific terms. Okay, we may have this breach or that breach, which is mostly the business to explain this kind of stuff. That's what I think. Thank you.
So I think on a flip side of that, there's also an opportunity for focusing what is typically a narrow security spend when you start shifting to cloud. So, as an example, if you're building a service and you're building it on top of several underlying cloud services, you first have to go through a valid IBM soft layers or whatever, or a platform service like IBM Bluemix or Azure's platform services, or any of that. You have to make sure that you trust them, right? So certifications, audits, all the types of stuff that you would actually do and analyze to validate you can truly trust the security that cloud provider is providing. But once you do that, it's sort of shrinks the scope of security that's left on your side of the house developing a solution on top of underlying cloud services. So you may have a small security spend, but if you can trust cloud providers that you're using as sub-providers under the focus that small security spend on a smaller sort of focus area. You might invest better in data security or much more robust forms of access control because you don't have to worry about lower level patching of servers or system network vulnerability scans because you're using a platform service that's providing some of that. So it can be a real opportunity to focus what is a small security budget.
Mm-hmm. Great. Another question came in about Cloud Security Alliance, and which is one of our partners here. So there seems to be a lot of standards around cloud computing. Does it seem that CSA, or Cloud Security Alliance, is emerging as the overarching standard or best practice for cloud security? Any thoughts on CSA's role in this space?
Yeah, I mean, this is Chris. So I don't know if that's entirely true. I mean, CSA, for example, the CAIQ is a terrific Rosetta Stone showing lots and lots of different standards and how they all link together. But in terms of the most popular standards that I've seen, it seems like really the ISO 27000 family of standards, especially in Europe, perhaps the NIST standards, FIPS 199-200 and NIST 853 is very popular in the U.S. and of course, and everywhere. Both are everywhere, and a few others. I don't know that there's any necessarily one standard that's everything's converging towards, and I think that's fair because I think the standards tend to have a slightly different focus. So I don't know if anybody else has any thoughts on that, but I don't think it's all converging on any one thing.
Yeah, I think they all have their pros and cons and their strengths. Chris, I would agree that CSA, Cloud Security Alliance stuff is typically a good way to sort of articulate and maybe produce spreadsheets and checklists worth of security controls in a way that someone can dive under the covers a bit. ISO 27000, that whole framework with 27002 controls, and you can get 27017 and 18 sort of cloud and privacy sort of adders on the side of it. What's really good about ISO is it's more than just a set of controls. It's really measuring someone's entire. You're getting more than just a snapshot in time set of controls. You're also getting an audit of the sort of governance and risk management and threat management processes that a company has in place, and the fact that they're actually improving and finding risks and closing them over time. You also CSCC 16 SOC 2 Type 2 audits are typically something that many customers look for nowadays as a good sort of lower level set of controls that really help, especially in the case of, say, infrastructure or platform services. So I really do, as you have to figure out what the right mix is. In some cases, it also might be best based on what your organizational security policies are, right? If all your internal IT security policies are, kind of based on a NIST framework or something else, and then you go off and look for ISO standards as your external certification from a cloud provider, that mapping is sometimes tough. And so you may want to have a certification that you tend to look for from a cloud provider that aligns with whatever your framework internally is. So there's lots of goods out there. You kind of have to use a mix of them.
Yes. And another question here is, do you have a cloud security best practice and guidelines for us to be used as a master implementation plan? And so I know from the Cloud Council perspective, there are 2 papers here up on the screen, security focused. You might want to start with our Security for Cloud Computing 10 Steps to Ensure Success. And if others on the call, if you have some suggestions of resources, feel free to chime in here.
No, besides like the Cloud Standards Council, CSA has some. There are others that are out there in the industry. I think the challenge sometimes to a checklist and a set of steps is people tend to use them just as that, right? Okay, well, here's a list. I just have to go do these things, and I'm going to be all good and covered. And the problem is that security is not that black and white. It's a threat. So the appropriate checklist for a given situation that someone may find themselves in is going to widely vary based on the data, based on regulatory situations, based on countries and regions that there would be in, and others, and really industries and attacks and industry sees. And so you really have to understand the unique risks and threats of whatever project, business situation you're in, and then pull from probably multiple sources to pull together a checklist that would make sense in that space. A generic checklist is very dangerous because it's going to miss things that might be focused on the unique aspects of what you're doing.
I think that the master plan is really hard to find because it depends on what you want to achieve, right? You may start from the discovery of what you have in terms of shadow IT, or maybe you want to implement some infrastructure as a service and you're going this way. You may have different goals, you may have different thoughts about how to implement that, and sometimes it actually depends on the provider that you're going to use, right, on their capabilities. So these guidelines that we have in CSCC will give you a starting point, good starting point, as well as CSA. You can see those controls, but you need to really think about what you're trying to achieve. Are you going to use software as a service? So then you may have any limited security implementation stuff, right, over there, because of it's probably controlled by the provider. So depends on your implementation, what you're trying to achieve. You may have a different plans in there. But you can use CSCC as a starting point to find out what are the best practices depending on these requirements.
Thanks, Alex. Last question here is, when addressing each of the cloud resources and services, app security, infrastructure security, etc., is there a sense of differentiation? Did I say that right? i.e. must-haves versus nice-to-haves, or maturity level centric?
Oh, so like if you've only got a little bit of money, which one do you do first? Yeah. I mean, if in my experience, and others may, on the panel here may disagree, but if you can only do a few things, identity management and vulnerability/patch management are probably up at the very top of the list, followed very closely by application security management. So that gets you a long ways towards being more secure, and for less, lesser severity workloads might potentially even be enough.
Yeah, I tend to agree, Chris. Most hacks, frankly, really map back to a very common vulnerability somebody simply never closed and never patched. Even maybe they didn't know it was there, or they did know it was there and never got around to performing the hygiene to close it. Or, as you stated, an identity hack, really simple passwords, easily guessable passwords, social engineered kind of attack. identity, basically logging into the system as an authorized user maliciously. Those are the most common ways that hacks occur. So I do agree that they're kinds of baseline foundations. But of course, no matter how much you invest in some of the outlying security, at some point someone is going to get in. That's the reality of IT nowadays. So I do think some elements of data protection are absolutely essential, especially a lot of the logging activities, the monitoring activities, be it at a data level as well as an access level, with very robust kind of tracking on that, so that when somebody gets in, you can detect it as quickly as possible.
Yeah, I agree.
Yeah, I think that one of the most important parts is the discovery, as I told before. So you need to understand what you have in your environment. You have some whitelisted solutions, right? But I'm quite sure that you have tens of different not visible solutions or shadow IT, right? So try to understand what you have, because of most of the shadow ITs, they use immature cloud services which can expose your data easily, right? So this is the point where you need to look into that and maybe use CASB solutions or some sort of next generation firewalls which can give you some capabilities to see what is going on.
Thank you, Alex, Vishnu, Bill, and Chris. We'll wrap up now. And thank you, everyone on the call, for participating. We appreciate it. Hope you have a great rest of the afternoon. And please join us at our next webinar. Thank you. Bye now.
Thank you. Bye.